Welcome to the Keystone Practice Test Notes. You're going to be given 10 problems today for class, and then you'll be given the exact same type of problems, 10 of those for practice to be graded. So when you sit down to take these keystones, you are going to make a perfect square list first. It's very important that you do this. Don't even start the test until you make your square list. You should be able just to do 1 squared is 1, 2 squared is 4, 3 squared is 9. Go up to 10 squared, okay? That should be enough. If it's not, you can always, sorry, that should be 5 squared. If it's not, you can always add to your list. But if you start, so the teachers are going to read you a lot of directions. Be patient and be kind to them, okay? Um, Giving the test is just about as much fun as taking the test. So please be patient and be kind to them. But after they're done reading you the directions, I am asking you as your algebra teacher to please make yourself a list of perfect squares as I just did. So 1 square, 2 square, 3 squared, all the way up to 10 squares. So you have your perfect squares. Now let's dive in and pretend we're taking the Keystone test. What is the value of x? Show all work. Now look, here we have a square root problem. You need to remember that this 4 square roots of 3 used to come from, so what is 4 the square root of? So let's use that list. 4 is the square root of 16. So 4 used to come from 16, and therefore this problem used to be the square root of 48. So this used to be the OG, the original problem before it was simplified. So they're asking what should this value of x be so that you end up with the square root of 48? Well, let's take a look at my red highlights. I need 48 to be the same as 24x. Well, that means if I divide both sides by 24, x better be 2. So what is the value of x that gives you 4 square roots of 3? It better be 2. I would like to prove this by doing 24 times 2, square root of 48. What on that list goes into 48? Not 36, not 25, but 16 and 3, which makes 4 square roots of 3. We did this in previous notes. I'm not sure if I could pull them up quickly. It would have been in chapter 13, maybe even in chapter 10. Uh, and if you care, that's great. If you don't, you can just fast forward through this part. I'm going to go back to chapter 10. You guys rocked out at chapter 10. So it was these ones whenever, so that would have been 10:3 if I can find a key. That's when we did this stuff. So just remember that the keystones are going to give you some multiple choice, kind of like this. So you can always plug those multiple choice items in. All right, back to our notes. So the value of x that satisfies that is x equals 2. Now for number 2. This has not been something I've really gone over with you, least common multiple, because that was from middle school. But you are super good at greatest common factor. So let's do the greatest common factor first, and then I'll reintroduce least common multiple from middle school. So we're given this monomial and this monomial. What is the greatest common factor? That's this side, greatest common factor of those two monomials. In other words, what goes into them? Well, what goes into 2 and 10? You guys know this. The answer is 2. Should I pick x to the 5th or x to the 3rd? Definitely x to the 3rd. So it's like, what do they both have? Should I pick y or should I pick y squared? I should pick y. We just did some GCF problems, so you say what goes into them. So each of them has an x to the 3rd, each of them has a y, and each of them can be divided by 2. Now the LCM is a different story. This we should probably review. You have not seen this since middle school. It's what do they go into? So think about 2 and think about 10. What does 2 and 10 both go into? Well, I know that 10 goes into 10, 10 goes into 20, 10 goes into 30, etc. 2 goes into 2, 4, 6, 8, 10, 12. So these are called multiples. So what is the least common multiple that they have in common? A 10. So 10 is the smallest thing that they both fit into, not what fits into them. Now, do you think that I should pick x to the fifth or should I pick x to the third? What do they both fit into? Well, x to the third fits into x to the fifth, but x to the fifth does not fit into x to the third, so I need to pick x to the fifth. Do you think I should pick y or y squared? Y fits into y squared, but y squared does not fit into y, so I must pick y squared. So with least common multiples, the answer is always either, it's usually bigger than both of them. Greatest common factor is what's smaller than both of them. Those concepts get reversed a lot on the Keystone. We'll kind of punch away at those a few more times because I think that's probably a hard concept. Number 3, factor this expression. So there is a GCF when we factor here. The GCF is 1. By taking a 1 out, it changes absolutely nothing. Now, we have just reviewed the ACB chart. AC is negative 40 and B is 3. 1, 2, 3, 4, and 5. It is going to be in this list. It's not 1 because when we divide and add, we get negative 39. It's not 2 because when we divide negative 40 by 2 and add that answer, we get negative 18. It's not 3 because we get a decimal. Let's see, negative 40 divided by 4 is negative 10. You add and you get negative 6, so that's not it. Now when you divide by 5, you get negative 8. Add, you get negative 3. Change, change, change. Draw your box. We now have the positive 3 that we need. We have our magic numbers over here. X squared goes here, negative 40 goes here, negative 5x and 8x. GCF here and here are x and negative 5. GCF here and here, x and positive 8. So the factored expression is x minus 5, x plus 8, and our GCF of 1. Just remember the keystones will not have the keystones will not have the GCF of 1 because they just don't put GCF of 1s. Number 4. Number 4, we're going to need to simplify. In order to simplify, we need to clean the numerator up. In order to clean the numerator up, you need to distribute this x so that you end up getting x squared minus 5x minus 14. Some of you might be weirded out by this thing right here. Just hold on, I'll explain that. For right now, just pretend you don't see it. And down here, this one's already cleaned up, but both of these are going to need the box. Let's do the numerator first. So the GCF in the numerator is a big fat 1, which changes nothing. So taking a 1 out, and I'm going to do with the numerator, everything about the numerator I'm going to do in a different color like red so that it sticks out and you know the numerator is red. So AC is negative 14 and B is negative 5. 1, 2, 3, 4, 5. As you work your way down the list, when you divide by 2, you'll get negative 7. Add is negative 5, which is what I need. X squared and negative 14 go in the caddy corner boxes, and 2x and negative 7x go there. My magic numbers. GCF is x minus 7 and x plus 2. And remember, we did everything in red is for the numerator. So x minus 7 and x plus 2. Now for the denominator, I'll stay consistent with that hunter green. For the denominator, the GCF is in fact a 1 again. Now this is squared. AC is 1 times negative 4, and B is 0 in this case. That is a hard thing for kids to remember, so I will therefore highlight it for something to study. 1, 2, 3, and 4, and 5. Divide by 1, not what we need. Whoopsie, I got too excited there. Divide by 1, not what we need. Divide by 2, exactly what we need. Go to your box, x squared, take away 4, 2x, negative 2x, x plus 2, x minus 2. I flew through that. I would highly suggest you either A, on YouTube, put me on like slow down speed, or B, try it on your own and come back and watch again. Okay? So everything I did in Hunter Green was for the denominator. Please don't forget that in the numerator and the denominator, we had that weird GCF of 1 and 1. But remember, GCF of 1, they really don't count for anything, so I didn't even bother with them. So what matches identical? The x plus 2's. So I'm left with x minus 7 and x minus 2 as my final answer. Now remember at the beginning I said you might be bugged out by that thing I have here highlighted in red. Those are called restricted values. Long story short, those would make your denominator equal to 0, so they're not allowed to have them. Hopefully you won't need to have that extra tidbit of information as long as you can do everything else. Let's go to number 5. Number 5 is asking what steps are missing. So what we're going to do is we're going to solve this. Remember I told you on the keystones, you can write all over the test as long as your final answers go into the answer sheet. So we are going to solve this normally. So this would be called the distribution step, which they already did for us. So you can see negative 2x plus 6 equals negative 6x minus 24. So what would we do at this step to solve this problem? Well, if you've been with me long enough, you know I always draw this fence, and I like to take my x's to the left. So I personally would add 6x. That would give you positive 4x plus 6 equals negative 24, because these will go away. Then we would minus 6 on each side and get 4x equals negative 30. And you can see that's where it leaves off. So the missing step would have been here. Okay, where they took the 6x to the other side. And that's totally fine. That was what the missing step would have been. So as long as you can show me what they missed, you will be good to go. Number 6. Deshawn has a box of batteries. Some of the batteries provide 1.5 volts each. The rest of the batteries provide 9 volts each. So it sounds like we have 2 types of batteries, folks, which means to me, I need to know, I'm going to do this one in pink and maybe this one in brown. So 2 types of batteries. The total voltage provided by the batteries is 78 volts. What is an equation to model this situation? Now I'm going to call the pink stuff X, and I'm going to call the brown stuff Y. So it sounds like 1.5 is the voltage for every X, and 9 is the voltage for every Y, for a total voltage of 78. Yes, I make that look easy. It's my job, so I better be good at it. But that is not an easy thing to do. So I had to identify there's 2 variables. What are they? Make an equation. There are going to be 10 batteries that are 1.5 volts. That, to me, I see 1.5 volts. So I'm going to make that pink and plug in for X. So 1.5 times 10 plus 9y equals 78. At this point, I'm going to draw my fence and solve. 1.5 times 10 is 15 plus 9y equals 78. Take away 15 to do our solving. 9y equals 63. Divide by 9. Y is 7. So it says how many 9 volts? 7 9-volt batteries. So make sure you either plug in for X or Y depending on what they say. Number 7, it's now time for us to graph a system of equations, and this should say, then show the solutions below. So then state solution. Okay, I'll fix that for yours. All right, so in order to graph this, oh, I did not want that green. That is a horrible color, purple. We are going to do one at a time. I'm going to graph that one first. My y-intercept is positive 1, so go to your y-axis, y to the sky, positive 1. Then your slope says go up 1 over 2, up 1 over 2. I am going to do that the entire length of the graph, and then I'm going to go in reverse so I don't screw anything up or miss anything. Some kids, for their first line, they just like to put like 1 or 2 dots. I do not encourage that because it could really mess up if you don't draw that thing perfectly straight. You know what? I will use that obnoxious color green. Why not? So now we're going to do our y-intercept of -1. And my slope says go up 3 and over 2. Am I burning your retinas with this color? 1, 2, 3, 1, 2. Oh, nice. I already hit. Once you hit, you're done, man. Um, you see the orange cable hanging down? It's that second drawer. Once you hit, you're good to go. You found the answer. The second line does not need as many as the first as long as you actually get an intersection like right here. Now here's the trick, guys. Remember, your solution is the x and then the y. So where do they cross? They cross at 2 and at 2. Oh, well, that's convenient that they cross at 2 and 2. So it's over 2 and then up 2 for a point. But the good news is you can't screw it up because it's 2 and 2. Calvin will plant lily bulbs and iris bulbs in his front garden. He will plant a total of 40, and just so you guys know, let's see, they're going to tell us what's what. They want lily to be X, and they're going to want iris to be Y. He will plant a total of 40 bulbs and three times as many, I'm sorry, I lost it. 3 times as many iris bulbs as lily bulbs. Woof! The graph is shown below. Lily's is X, and they already did that for you, and iris is Y. Write a statement describing the point of intersection. So the point of intersection is right here, and that is over 10 and up 30. Oh my. All right, so the intersection is at 10 comma 30, which means 10 is my x-axis. So that means 10 lily bulbs. And I could make a statement. I could say he plants 10 lily bulbs and 30 iris bulbs. Beautiful statement. Oh, something to practice on the keystones. I'm so glad I thought about this. Your answers have to stay in the box. So if you are a person who writes large, don't. I'm sorry, it stinks. I tell my daughter the same thing because she is a big writer. Now, what is the equation from this statement? He will plant a total of 40 bulbs. So in order for me to explain that, remember we had X for Lily and Y for Iris. You just add those to equal 40. And then what equation says 3 times as many iris as lily bulbs? That means that your iris bulbs have to be 3 times your amount of lily bulbs. So the lily bulbs have to get multiplied by 3. So let's just change that. Lily was not L, was it? Remember Lily, they wanted us to use an X. Sorry, that can be very confusing. And then Iris, that's a Y. The good news is maybe they'll just ask you about the graph and not making the equations because this one is really hard for kids to think about. But just remember, the iris bulbs have to be 3 of the lily bulbs. That's what that statement says, kind of if you word it a different way. All right, number 9, graph the inequality. Great, we are so good at these. Do you guys remember there's 2 answers? 2x minus 1 is less than 7. 2x minus 1 is greater than -7. Add 1. 2x is less than 8. Remember over here we flip and flip. Divide by 2. X is less than 4. So now let's just shrink this down, okay? I'll put that right there. And now I'm going to do this side. Remember, we flipped it to a greater than and to a -7. So we need to add 1. 2x is greater than -6. Divide by 2. X is greater than -3. You don't flip, you're not dividing by negative, so that's not going to flip again. We already flipped it once. Shrink all that down. All right. Now, this was an and problem because it says less than, so I need to look for an overlap. So here is, let's just call this 0. 1, 2, 3, oops, 3, 4, -1, -2, -3. Both of them are open circles. Now let's see, this one says less than 4, so it goes this way. This one says greater than -3, so it goes this way. So the overlap is from here to here. And all the extra crap can go away. So your answer is that. So you're looking for overlap because it's an and. Number 10, and then we're done, okay? Oh, graph the inequality. This is not a double answer problem at all, okay? This one, I'm so sorry about that. This one's a normal solving. So this side needs distributed. This side needs to stay the same. This 3 needs to move over. So that's -1 plus 3 is 2. Those cancel. Then this 2 needs to come over. 2x is greater than -8. We're not dividing by negative, so don't flip your sign. And then divide by 2. X is greater than -4. Again, please do not, don't flip your sign because you're not dividing by a negative, okay? And this is just a one-liner. So let's do 0, 1, 2, 3, -1, -2, -3, -4. Open and greater. So that is the answer to that one. It's not an overlap or an ors of a boat. That's just one. It's not an absolute value problem, okay? And that takes care of the first 10 problems on the practice Keystone test that were given. Now you have 10 problems to do that are identical to these. I just changed the numbers or changed the problems or the word problems. Best of luck.